What if I told you that a machine built before most people watching this were even born just did something no human hand will ever undo? It slipped past an invisible wall at the edge of our solar system, and what waited on the other side made scientists rewrite decades of textbooks in a single day. Something out there is not what we thought it was, and the truth is a little unsettling. Before we go any further, if you love stories where real science feels stranger than fiction, hit that like button, subscribe, and share this video with one friend who still stares at the night sky and wonders. That single click helps this channel more than you know. Now let me take you back to a very specific moment. November 5th, 2018, a tiny spacecraft, no bigger than a small car, is drifting through the darkness roughly 11 billion miles from your living room. It has been flying for 41 years. Its computers are older than most of your appliances. Its memory is smaller than a modern text message. And yet, on that quiet November day, its instruments suddenly notice something impossible to ignore. The particles around it change, the magnetic field twists, the temperature spikes. In less than 24 hours, everything about the space surrounding this little machine flips. And just like that, Voyager 2 becomes only the second human-made object in history to leave the protective bubble of our sun. It enters true interstellar space, but this is not just a feel-good story about a plucky spacecraft going the distance. This is a story about a boundary we thought we understood. A boundary scientists had modeled, simulated, and drawn for 50 years. And when Voyager 2 finally punched through it, the readings that came back were so different from every prediction that not one, not two, but 5 separate teams of researchers rushed to publish 5 different papers on the exact same day. That kind of coordinated release almost never happens in science. It only happens when the data forces it. It happens when reality has surprised everyone at the same time. To understand why this matters, you have to understand the edge. If you were taught in school that the solar system ends around Pluto, I need you to gently let that idea go. Pluto is not the border. Pluto is not even close. Pluto still sits deep inside a giant invisible bubble that our sun controls. That bubble is called the heliosphere. Think of it as an enormous balloon of charged particles flowing out of the sun. This solar wind moves in every direction at hundreds of kilometers per second, pushing outward further and further. It continues until it slams into the pressure of the space between the stars. The place where those two forces meet is the heliopause. That is the true edge. That is the doorway. Cross that line and you are no longer inside anything your star built. You are in the galaxy itself. To reach that doorway, Voyager 2 had to travel for 4 decades. It launched in August of 1977, back when disco was still on the radio. It flew past Jupiter in 1979 and Saturn in 1981. It flew past Uranus in 1986 and past Neptune in 1989. And then, mission technically complete, it kept going. It just kept flying outward, quieter every year, colder every year, further from home than any object except for its twin. Decade after decade, it slowed slightly under the sun's gravity, but never enough to stop. And on that November day in 2018, its plasma sensor suddenly went silent in the best possible way. The solar wind, that steady stream of particles from the sun, dropped to almost nothing. Cosmic rays from deep space jumped sharply. The magnetic field around it shifted into a new pattern entirely. Voyager 2 had just walked out the front door of our solar system. Now here is why this crossing mattered so much more than the first one. Voyager 1 had already left back in 2012. But Voyager 1 had a problem. Its main plasma instrument, built to measure space properties, had died way back in 1980. So when Voyager 1 finally reached the edge, its most important tool for describing the crossing was already 32 years dead. Scientists had to piece the story together from indirect readings, from clues and shadows. Many fundamental questions stayed open. Voyager 2 was different. Somehow, against every reasonable expectation, its plasma science instrument was still working after 41 years. It was still calibrated and still sending data through the freezing radiation of deep space. This changed the game. So when it crossed the heliopause, for the first time in history, we had a working set of eyes on both sides in real time. That is what made this moment historic. That is why the whole story exploded across the scientific world. And what those eyes saw changed everything. Quick pause. If your mind is already a little blown, do me one small favor. Tap that like button right now. Not later, not at the end, right now. It helps this deep science story reach more minds. And if you have not yet subscribed, this is your sign. We tell these stories every single week, the way they deserve. Okay, let us get into what Voyager 2 actually found, because this is where the surprises begin. The first shock was the boundary itself. For decades, scientists assumed the heliopause would be a soft, fuzzy region. They expected a slow blend, like two rivers meeting and mixing gradually until you cannot tell where one ends. That was the picture in every textbook. That was the assumption behind every model. But Voyager 2 saw nothing like that. What it saw was a knife edge. a wall. In less than a single day of travel, the entire environment flipped. One day, solar particles. The next day, galactic particles. One day, our sun's magnetic field. The next day, the galaxies. The paper describing this put the width of that transition at less than 0.06 astronomical units. To put that in human terms, that is less than 6% of the distance between the Earth and the Sun. In space physics, where distances are measured in millions of miles, that is razor thin. That is not a border. That is a slam. The second shock was the temperature. Everyone expected the interstellar medium to be freezing cold near the boundary. The models had predicted a specific temperature range, and it was low, but the plasma out there was warmer than expected. Not warm in the way a summer day is warm. This is still an environment that would kill you in seconds. But warm in the sense that our models were clearly wrong. The universe between the stars is not the cold void we imagined. It is livelier. It is variable. Its properties actually change as you move through it. There is weather out there. The third shock came from the magnetic readings. Just inside the heliopause, Voyager 2 detected a magnetic barrier. This is a zone where the magnetic field suddenly gets much stronger, forming a kind of invisible shield sitting just inside. This barrier acts like a bouncer at the door of our solar system. It slows and deflects cosmic rays trying to push in. Voyager 1 had hinted at this, but its data was blurry. Voyager 2 confirmed it in clear focus. And this matters more than it sounds, because those cosmic rays it deflects are dangerous to life and electronics. They come from supernova explosions and violent events. They travel at nearly the speed of light and can damage DNA. That invisible magnetic shield at the edge of our solar system is one of the reasons life on Earth evolved in peace. And we only just learned how it actually works. The fourth shock is the strangest of all. Because Voyager 2 crossed at a different location and direction, scientists could finally compare two spots on the boundary. And what they found is that the bubble is not a bubble. Not really. Not the perfect symmetrical sphere we drew. Well, Voyager 2 saw a thinner boundary than Voyager 1 did. It saw stronger magnetic fields and different plasma conditions. The heliosphere is lopsided, squashed in some directions, stretched in others. It has a shape more like a slightly deformed shell. It is twisted by the sun's motion through the galaxy and by whatever interstellar wind it happens to be pushing through. That means the shield around our solar system is not equal in every direction. Some parts are better protected than others. The cosmic radiation reaching us right now depends, in part, on which way we are facing in the galaxy. This is now fact. And the fifth shock might be the biggest of all, the pressure. Models assumed the galaxy pushed back with a certain force. When Voyager 2's magnetometer sent home measurements, that number was off, way off. The field is 2 to 3 times stronger. The pressure it applies on our heliosphere is up to 10 times greater than the old models assumed. 10 times. That is not a small correction. That is a rewrite. It means the galaxy is squeezing our sun's bubble much harder than realized. It means our protective shield is fighting a stronger opponent than we knew. And it raises a quiet, uncomfortable question. What happens if that outside pressure ever grows even stronger? What if our sun drifts into a denser region of the galaxy? The bubble would shrink. The protection would weaken. More cosmic rays would slip through. That is a real possibility that scientists cannot fully rule out now that we know how forceful the outside pressure really is. Take a breath. Because I want to say something important. This is the kind of story that most people will never hear. It will not trend. It will not make headlines. But it changes the way we understand our place in the universe. So if you are still with me, I want to ask you a small favor of a different kind. Do not just like this video. Share it. Send it to someone who needs to feel a sense of wonder today. Someone who has forgotten how big and strange the universe really is. That single share is worth more to this channel than 1,000 silent views. Now let us keep going, because the story is not done. All 5 of those discoveries landed on the same day, November 4th, 2019, exactly 1 year after the crossing. 5 different research teams, 5 different instruments, 5 different papers, all published together in Nature Astronomy. The scientific community did not panic, but it did pause. Patrick Coyne, a senior scientist at NASA, described Voyager 2 as, quite literally, a pathfinder. And that word matters. A pathfinder is not just an explorer. A pathfinder is the first one through the door, the one who comes back and tells you the map was wrong, the one whose data forces everyone else to draw a new one. That is what Voyager 2 did. Everything we had drawn about the edge of our solar system needed to be redrawn. Everything we had taught in every classroom, everything we had modeled in every simulation, the sharpness of the boundary was wrong. The temperature outside was wrong. The strength of the magnetic barrier was wrong. The shape of the bubble was wrong. And the pressure of the galaxy against us was wrong. All at once. And yet, here is what I love most about this story. Voyager 2 is not done. It is still out there. Right now, as you watch this, that little spacecraft is still flying deeper into interstellar space, still measuring, still sending signals home, signals that take more than 18 hours to reach us, traveling at the speed of light. And every one of those signals is a whisper from beyond the edge of everything our sun built, everything our species has ever called home in any physical way. Since the crossing, Voyager 2 has kept mapping the interstellar medium. Not a map of continents or oceans, but a map of conditions. Plasma density here, magnetic field direction there, cosmic ray counts everywhere, and the story that map is telling is even stranger than the crossing itself. Because that space out there is not still. It ripples, it shifts, it reacts. When the sun sends out a giant flare, a solar shock wave can push all the way through the heliopause and into interstellar space, and Voyager 2 has actually felt those shock waves passing by. It is like the heliosphere breathes. It inflates, it contracts, it responds. And on the other side of the wall, the galaxy responds back. Two environments forever pushing against each other in a relationship no model had accurately described. Until this 141-year-old spacecraft finally showed us the truth. But there is a sadder side to this, too. Voyager 2 is dying. Slowly, but truly. Every year, its plutonium power source produces about 4 watts less energy than the year before. Every year, engineers at JPL have to make painful choices about which instruments to shut off to keep the mission alive. Cameras were turned off long ago. Heaters have gone dark. Systems that once ran freely are now rationed. And at some point in the coming years, the little spacecraft will lose the strength to whisper home. It will still be moving. It will still be traveling further into interstellar space. But it will be silent. A silent metal traveler drifting outward forever. And when that day comes, we will not have another. No replacement mission has been funded. No spacecraft is currently on its way to interstellar space. The only 2 objects ever to leave our solar system are already out there, aging with every passing year. When Voyager 2 goes quiet, the direct measurements stop. The map stops where it stopped. Whatever lies further out, at greater distances into the local interstellar cloud, will remain unknown. Maybe for decades, maybe for centuries. Because right now, no one is going out there to look. Think about that for a moment. The only 2 eyes humanity has ever placed beyond the sun are slowly closing. All right, we are past the halfway mark. And I want to ask you something, honestly. Are you feeling it? That strange mix of awe and wonder and just a little bit of chill down your spine? If you are, I want you to comment 1 word below. Just 1. The word that describes how this story is making you feel right now, whether it is wonder, sadness, curiosity, or something else. That 1 word helps this video reach more people who feel the same. And if you have not tapped subscribe yet, this is your gentle nudge. Stay with me. There's still more to come. Now let me take you deeper into one specific finding, because it is the one that connects Voyager 2's story directly to your life, directly to Earth, directly to the reason you and I exist at all. That finding is about the shield, about cosmic rays, about what protects life on our planet from the violence of the galaxy. Cosmic rays are not gentle. They are the leftover shrapnel of exploded stars. They travel at nearly the speed of light. They can pass through metal, through concrete, through the human body. On Earth, we are shielded from most of them by 2 things: our atmosphere, and more importantly, our heliosphere. That giant bubble around our solar system deflects and slows most of the cosmic radiation from the galaxy before it ever gets close to us. Without that shield, life as we know it would look very different. Mutation rates would rise. Radiation-driven damage would climb. Atmospheric chemistry might shift. Some scientists even believe repeated exposure to elevated cosmic ray levels could influence long-term climate. So the shield is not just an interesting bubble on a diagram. The shield is why you are here. The shield is why life had the time and stability to evolve on this planet. And what Voyager 2's crossing revealed is that this shield is more fragile and dynamic, and more shaped by the outside universe than we had ever assumed. That extra pressure from the galaxy, 10 times stronger than the old models believed, means our bubble is being squeezed more than we knew. That does not mean the sky is falling. It does not mean cosmic disaster is coming next Tuesday. But it does mean the calm, quiet safety we live inside is not as permanent or as guaranteed as we once thought. The heliosphere breathes, and the galaxy pushes back, and the balance between them is the reason we get to live our lives. Without noticing any of it, it is worth pausing on that. There's another discovery buried in the crossing data that quietly amazed the scientists studying it. Both Voyagers reached the edge of the solar system at roughly the same distance from the Sun, about 120 astronomical units. But they crossed years apart, and they crossed during very different phases of the Sun's activity. Voyager 1 crossed during a solar quiet period. Voyager 2 crossed during a much more active one. Logic said the boundary should have moved. When the Sun is more active, it produces more solar wind, and that wind should push the boundary further out. When the Sun is quieter, the boundary should pull back. That is what every model predicted. But that is not what happened. The boundary stayed almost exactly where it had been. And the meaning of that is subtle but powerful. It means the galaxy outside is doing most of the work in setting where the edge lives. Our sun blows the balloon, yes, but the galaxy is the one deciding how big the balloon gets to be. The sun does not get to choose. The universe does. Something about that hits differently. Our star does not fully control its own boundary. It negotiates. It pushes as hard as it can, and something older, vaster, and quieter pushes back. And they meet, and they hold. And the line where they meet is the wall Voyager 2 crossed in 2018. In 2023, we almost lost Voyager 2 completely. Someone at NASA sent an error command. It nudged the antenna just slightly off Earth. Voyager 2 went silent for 14 full days. No plasma readings, no magnetic data, no confirmation that our furthest scout was even alive. Then engineers sent an interstellar shout. A powerful command blasted at the spacecraft, and it heard. Voyager 2 was built by regular people, with computer memory smaller than an email attachment today. Yet it walked out of our sun's kingdom and stood in the naked light of the galaxy itself. Somewhere out there, its power is fading and its voice growing softer, but its story is getting louder. It showed us that the edge of the solar system is sharp, warm, crooked, and crowded. It showed us the shield we live inside is smaller, stranger, and more precious than we realized. Someday, it will send its last signal, but it will keep drifting with our golden record forever. That darkness in the sky is not empty. It is thick with plasma and alive in ways we are just beginning to understand. If this story moved you, share it with someone who needs a little wonder tonight. Because the smallest, quietest travelers are the ones who go the furthest. Thank you for watching. I will see you in the next one.